Hey guys, welcome to another USACO video. I know I've been away and taking a little break from USACO for the last few weeks, but in my YouTube channel I've still been uploading random stuff that are not related to coding, so make sure you go check those out. But today we're back doing the 2017 December contest, Silver Problem, Milk Measurement. And in this problem, Farmer John has an infinite number of cows that initially all produce G gallons of milk per day. And Farmer John also has a log that records the day, the cow, and the changes in her milk production. And so it's going to look like this. And this just means that on day 35, cow number 1234's milk output was 2 gallons lower than it was last measured. And for this one, similarly, on day 14, cow number 2345 will have increased 3 gallons in her milk production. Okay, so in addition to this, Farmer John also has like a wall of fame in the farm. And the wall of fame is just gonna record all of the cows who has the most milk production currently on that day. So if many cows are tied for having the most milk production for that day, then the wall is going to contain all of them together. And as the milk production of cows change, the wall is going to change as well. And so our job is to find how many times the wall actually changes. Alright, jumping right into the sample input, our n is 4, which means that we have 4 logs over here, and our g is 10, meaning that all the cows initially produce 10 gallons of milk. And so here's my little table of the cow number and the number of the gallons of milk it produces. And I've written these 3 dots here to show that it goes on infinitely. Okay, let's look at these logs. So the first one represents the day. The second column represents the cow. And then this represents the milk. And so we can see that the day is not sorted, and it will be very beneficial for it to be sorted because then we can just go down the list. And so let's sort the days real quick. And now it is sorted. Okay, so now we can go down from the top to the bottom, and we can update the cows as needed. And so for the wall of fame over here, all we have is just every cow. So 1, 2, 3, 4, 5, and it goes on infinitely. Okay, so on day 1, we're gonna have cow 1, and it's gonna add 2 milk. Okay, so let's do that. So now 1 is gonna have 12 milk. And we need to change the wall of fame here to update it to just 1 because it has the most number of milk. And so here it is, 1. And for our count here, let's just record we have changed it 1 time. Okay, now on to the next day is day 4. During the period between 1 to 4, notice that we're not changing anything here because nothing is changing, so therefore the wall cannot change. And so on day 4, we see that that cow number 2 subtracted 1 from its milk production. And so from here, we're just doing 10 minus 1 is 9. And in the wall, we're not going to change anything because 1 is still the cow with the most milk. Okay, so let's look at 7 now. For day 7, we're going to add 3 to cow 3. So this becomes 13. And now you can see that cow 3 now has more milk than cow 1. And so we need to change that. So here you go. And we're going to record 1 here because we changed it 1 more time. Okay, last one. On day 9, cow 3 subtracts 1 milk. And okay, so 13 minus 1, that's 12. And now you can see that 1 and 3 are both tied. And so we're just going to add 1 to the wall of fame over here. And so we can record 1 more because we changed it. And so in total, we can see that we have changed the wall 3 times. Okay, so at first, this problem might seem very easy because all we can do is that we can just, so every time something changes, all we need to do is cycle through everything again and see which cows have the most milk. Well, while this idea works and is very simple, because we have 10 to the 5 number of logs, so and we have an infinite amount of cows, this is going to be a bit hard on time complexity. So this is going to be too slow and it's not a complete solution. And then you guys might be saying that, oh, why don't we just keep track of the maximum milk right now? And while we could do that sometimes, so let's keep track of it. So let's say the current one is 12, so the maximum milk we have is 12. And let's say when 2 changes to 13, when it exceeds it, then we can change the max to 13. And now we're going to change it to 13 and we're going to record 1. And that does work until the max starts falling down. Until the max, it changes back to, let's say, 7. If the max changes back to 7, how would you know which cows would be next? You don't really know. You have to cycle through it again, or you have to keep track of a sorted list of some kind, and that would be pretty confusing, and the time complexity wouldn't look too good either. But so how do we actually do this problem? Well, what we can do is that we can make 2 maps. One maps the cow to the milk production, and one maps the milk production to the cow. So in here, we have a bunch of cows, we have a bunch of milks associated with it. So we can just say, so that is going to be our first map over here. So that's going to be our first map. So map number 1 is going to map the cows as the key and the milk as the value. Okay, but having this one map isn't really enough. We need to have another one. We need to have one that says milk to cow. And this one is just going to keep track of how many cows have this amount of milk. And so in here we can see 12 over here, so we can record 12. How many cows produces a milk of 12? Well, currently we have 2 cows that does that. How many cows produce a milk of 7? One cow. How many produce a milk of 10? 2 cows. And actually, because G is 10, so an infinite amount, and we have an infinite amount of cows that are producing G, which is 10, we're gonna have infinity over here, or just a very large number. We have infinite 10s, we have 1 7, we have 2 12s. Okay, great. Now that we have both of these maps, how do we actually maintain these maps and update them while we go through this array over here? Well, I can show you. So let's say right now that well, first let's record the cow that produces the most milk, so like the wall of fame. So in the wall of fame, currently we have 1 and 3 tied with a 12. So wall of fame is going to have 1 and 3. Or world of fame, we're just going to have 2 cows. Just going to record 2 cows is sufficient. And for each of those cows, it's going to produce 12 milk. 12 milk. And that is the wall of fame right here. So now let's add something. Let's say cow number 2, it added, let's say, 6 milk, and it became 13. Okay, so cow number 2, it was at 7, now it became 13. So we can directly change this to 13, but we also need to change something else. We also need to change this map over here. And so now that we don't have the 7 over here, we're gonna subtract 1 in the cow. And so this is gonna become 0. And when it becomes 0, that is the same as not having it. So we can just remove this entry altogether. And then we also add one to 13. We have one more cow that produces a milk of 13. So let's just do 13. I'm going to say 1. Okay. And now we're going to check, we're going to find the most milk produced in this map over here. Okay. So as you might know, in a map, you can just find the maximum key instantly because map is automatically sorted and is optimized. So in here, we can just find this 13 instantly. And it says, okay, we have a milk production of 13 as our maximum milk production, and there's one cow that does that. Okay, so now we check back to our wall, and initially we had 2 cows of 12 milk. Now we have 1 cow of 13 milk. And obviously, the wall has changed, so we need to update everything. So right now, let's just update this into 1 cow with 13 milk. Okay, great. So now let's say, okay, let's say 2 updates again. Let's say 2 becomes 15. 2 becomes 15. And so it was at 13, but now it became 15. And so we need to remove 1 from map 2 with a milk production of 13. So if we remove 1, it's going to become 0, and 0, we just wipe it out. And that's going to be 15, and we're going to have 1 cow producing 15. Okay, now if we try to find the max, we're going to find this, and this in here is 1 cow and 15 milk. And in this case, although the milk changed, the cows still haven't changed. And this is actually a corner case that we're going to be looking into. But normally, if the milk changes, mostly the wall is going to change too. So the cow picture is going to change. But in this case, because we only have 1 cow, and that cow was already the top, and it just beat itself, the wall still doesn't change. So in this case, it's not going to change. But we still need to change this to 15 milk. Okay, let's see. Let's update, let's say 4, we're going to update it to 15. So initially it was at 10, now we're going to put it as 15. Okay, so we can directly change this, but for map 2, we need to subtract 1 from 10. And 10 is already infinite, so subtracting 1 wouldn't do much. And because it changed to 15, we're going to change this, we're going to add 1 to 15. So that's going to be 2. Right, this better. 2. Okay, so now let's find the maximum milk again. It's going to be this. And now we have 2 cows and 15 milk. So will the wall change? Well, yes, it would, because if any time the cow changes, the wall is going to change automatically, even though the milk stays the same, decreases, increases, doesn't matter. The wall is going to change. Okay. So let's update it to 2 cows. And let's do our final example here. Let's say 2, it fell back to let's say 11. Okay, so 2 fell back to 11. So it was at 15, right? And now it fell back to 11. We can directly change this, but for this one, we need to subtract 1 from 15. So now it's going to be 1, and it fell back to 11. We're going to add 1 more in 11. And again, we're going to choose this, and we're going to see that it's only 1 cow, and so that means we have changed our wall again. So we're just going to keep doing this until we run out of days to go through, and that would be the solution. Okay, let's hop right into the code for this problem. We're going to first read in our N and G, and we're going to have 2 maps as we talked about before, cow milk and milk cow. So cow milk is going to have cows as keys and then milk as values, and the milk cow is going to be our map number 2, which has milk as keys and cow as values. And so in the cow milk over here, we're going to first say that the cow milk of 0 is G. And so 0 is not really a valid cow because cows only range from 1 to 10 to the 9, I believe. And so 0, we're never going to get this cow 0, and 0 is never going to change. But we know that we have an infinite amount of cows that have milk production of G. And so we can just say 0 because it's never going to change. And if every other cow falls behind this 0, we still have this 0. We're going to see that as the maximum production of G. And so next we're going to have milk cow that converts the milk produced into how many cows did that. And so initially every cow, which is infinite amount, is going to produce G milk. So we're going to say G is a very large number, which is the maximum integer over here. And now we're going to read in our logs. And the logs is just going to be a double vector. We're going to have n logs, and each log is going to contain 3 values. So we're going to see in everything over here, and we're just going to say initially the cow of the cow introduced is going to have G milk. And so this is going to get all of the distinct cows and add it into cow milk and say that all of them have initially G milk. Okay, pretty straightforward. Okay, now let's sort the logs based on day, and because day is the first element in this vector over here, it's going to automatically sort it by that, which is very, very cool. Next is our wall of fame. So top milk is the top milk production in the wall of fame, and cows is going to be how many cows are in that wall of fame. And currently you can see that top milk is G and cows is infinity. And now we're going to set our result, which is how many times we change the wall to 0. Okay, now we're going to actually do the logs. So we're going to cycle through each log, and we're going to say, okay, for this log, what is the cow milk? And so what is the current milk that is produced by this cow in the log? And so we're going to store that into milk. And new milk is going to be the changed milk. The milk after it got changed based on the log. So that's just going to be the initial milk plus whatever change we're giving. So the change is right here. This one's what we're looking for. Okay, so now we have the milk and the new milk. We're going to update the cow milk. And so cow milk, this map is just going to map the cow to the milk. And because we just changed it to new milk, we're going to set the logs I1, or the current cow, we're going to set its milk production to new milk. But we cannot only do this this map, we have to do also this map. And so this map maps the milk from the cow, and it's going to be a little more complicated. But basically, all it does is it says the initial milk, we're going to subtract 1 from the amount of initial milk because that cow just changed. And if we subtract it until it's 0, we're going to get rid of this entry in the map completely. And then we're going to say the new milk, we're going to add 1 more cow to that. So that means there's 1 more cow that produces our new milk. Okay, after changing these two maps, we're going to get the top scores based on them, based on the changed one. So our new top milk is just going to be milk cow .rbegin. That's going to give you the largest, the first. So the first is going to give us the milk, and this is going to give us the largest. So we're going to get the largest milk currently. And now we have the new cows, which is just going to be the same thing. We're going to get the entry that has the largest milk production, and we're going to get the second, which is how many ever cows that produces that many milk. And so now we're going to check these new top scores against the old top scores. So if the new top score or the new top milk is not equal to the top milk, or the new cows is not equal to the cows. So if the milk changed or the cows changed, then we need to do something here. And here is the corner case that we have been talking about. When the cows, the number of people, the number of cows on the wall of fame is equal to 1, and after we changed everything, it is still equal to 1. So that indicates that there's only one movement on the wall of fame. And so basically here, let's get a visual over here. So here are our milk production here. And so for this one, we only have one cow. And after one thing, we still might only have one cow. So that is the case that we're talking about right now. And the milk is equal to the top milk. And so the milk is just the current cow's milk before the change. It's going to be equal to the top milk before the change of the top milk. And the new top milk is going to be equal to the new milk. So what we just changed is the new milk. And what we didn't change was the new milk. So that is a case where it's like this. So we have this cow over here already leading, and so that means cows equals to 1. And after its change, so its change is going to be right here, it's going to grow a little bit. And so after its change, we still have one cow that produces the most milk, right? And our new top score is equal to the number of milk that it changed to, plus our old top score was over here. That is also going to be equal to the milk that it was just produced. So this basically states that basically the highest, the cow that is already the highest, the one cow that is the highest changes and becomes the highest again. And so in that case, it can set a new record for itself, but the wall of fame is never going to change because it's still this cow. So in that case, it's when the top milk cow changes and it's still the top milk cow, we're going to just change the top milk, but we're not going to add one to the result because we never changed the wall. So continue just basically loops around it again, and it's not going to execute this code. But this code is executed when it's not the corner case, and either the top milk changes or the cows change. Then we're going to add 1 to the result, and we're going to update the top milk and also update the cows. And that is it. So when I was doing the problem, one of the most difficult roadblocks I ran into was probably the corner case that was just presented, because I thought the double map method would work, but I had doubts when the thing that I submitted, there was a lot of wrong cases, and then I figured out that it was the one corner case that USACO has set for us. And I think this problem isn't that hard, but it is a little bit tedious to do, and there is corner cases, so that I guess makes it somewhat hard. But thank you guys for watching this video. If you have a problem that you want me to explain, please leave it down in the comments. And yeah, I hope you enjoyed. I'll see you in the next USACO video.